Welcome, everybody. Yossi Elran is the director of the Innovation Center at the Davidson Institute of Science Education, which is the educational arm of the Weizmann Institute of Science in Israel, in Rehovot or something like that. I probably pronounced it wrong. Yossi's background is in science. After getting a PhD in theoretical chemistry, he did research in quantum mechanics, but now he is a recreational mathematician at Davidson. And he uses recreational math to inspire kids of all ages, to think creatively. He has put on several large celebration of mind festivals at Davidson, and he also offers online classes. I want to tell you my personal favorite thing about Yossi. So you have to know a little about me for that. So I met Yossi about 5 years ago through math circles. I run math ellipses in Santa Barbara, which you see behind me. And math ellipses are just like math circles, except they're more eccentric. And one of the eccentricities is that I always dress to match the topic, just like I'm wearing a G4G shirt now. The one that my students appreciate more is that I always serve a snack that matches the mathematical topic. But I am far more impressed at what Yossi did to match his math circles. He started everyone with a magic trick that matched the topic. And I think that is so cool. I love magic. I love matching. I just love that. The title of today's talk is All You Need Is Paper. And the subtitle is Puzzles for Lockdown with Nothing More Than Some Regular Sheets of Paper. That title is also the subtitle of this book, the paper puzzle book, which Yossi co-wrote with a couple of people. He'll maybe tell you about that. Now, last week we did have several talks about folding and cutting paper. We had origami alphabets, kirigami spinners, hexaflexagons, but what Yossi is doing is totally different. This is going to be about doing math, solving mathematical puzzles by folding paper. So we're not making anything that you want to save. We're not creating something beautiful. We're doing math. And so this is a great time to use up all that junk mail that you get, because it doesn't matter. He'll also tell us a little bit about paper.
So I'm going to talk about paper of puzzles. This is a photo of the celebration of mind in Israel, one of the celebrations of mind. We have quite a show out of people coming. Usually the presentations for Celebration of Mind, I know a lot of you were watching probably know me from G4G Gathering for Gardening, who runs Celebration of Mind. The activities that we usually do for Celebration of Mind are usually more educational. So if there are some of you who know the stuff that I'm doing, so I apologize. But I also think and know that there are some people who are joining this presentation. This also might be on the web. So it might be not that new, but it will be, I hope, hopefully interesting, and hopefully I'll be able to persuade you that there's a lot of stuff you can do and even challenge yourself during lockdown with a piece of paper. And the things that I'm going to show, most of them are from this book, the paper puzzle book that I wrote together with origami artist Ilan Garibi and David Goodman, who was they're both Israeli puzzlers as well. And it was published by World Scientific, and came out, I think, a couple of years ago. I'm now, in a few months, a new book is coming out also with the World Scientific on recreational math. I also give courses, online courses in recreational math on the MOOC platform. That's a massive open online course platform called FutureLearn. On math puzzles and introduction, which gives an overview of what recreational math is, and on flexagons, which is one of the things that I do with, which I love to do with paper. But I know you've got a presentation by Anne Schwartz, who I work with a lot on them, so I'm not going to talk about flexagons today. I am going to talk about paper though, and this is a piece of paper. And here in Israel, we use the A sets of paper, which start with all sizes of paper are taken from one big sheet. And for the case of the European and Israeli paper, these are the A sizes. And the size of the largest piece of paper is 1,189 millimeters on 841 millimeters. So that's pretty large. That's 1 meter, 1.19 meters nearly on just under a meter. But the interesting thing about the ratios of this on the A4 paper is that their ratio is 1 to the square root of 2. As you can see, the numbers that I said before are approximately because the square root of 2 is irrational, but it's approximately the fourth square root of 2 meters over 1 over that. And the nice thing about this is you can see that the different sizes are obtained by folding it over. So we take A0, fold it over once, we get A1 sheet. And if we fold it over twice, this is not an A0, right? This is A4. I'm just demonstrating. And if you fold this over the other direction, you get A2 and then A3 and then A4, which is the full size of this. But the nice thing about the A series is that they keep the ratio of square root of 2 to 1, however you fold it. And this is because the square root of 2 is over 2 is equal to 1 over the square root of 2. So and this is the only ratio which will do that, which is kind of nice, I think. This, of course, is different in the US, which use inches, and they use these size papers. So also, it's taken from 1 sheet of paper, and the size of the paper are 44 inches over 34 inches. And the largest paper now is called, by letters, it's called E. And when you fold it in half, you get D. And when you fold that in half, you get C. So you're always having the area of the piece of paper, but now it no longer retains a constant ratio of length to width. The constant ratio of length to width in the A4 piece of paper allows you to do some neat things. So what can you do with a piece of paper? Well, my first challenge is, can you make a rectangle to a square? So now I'm challenging you, and I don't know, I can't see you, so I don't know if anyone's done it or not. But the idea is to take a rectangle and make it into a square. So I'm going to assume that you're doing this. I've even left you on the website, there's a PDF of 3 more challenges if people like these kind of challenges. But it's, of course, if we take this as just 1 unit, if we want to, we're going to have to mark somewhere on this side the 1 unit, and we're, of course, going to fold it like this. I'm trying to do this in the air, which is a bit difficult, right? To mark this end over here. And, just straighten out the diagonal. And we get a nice isosceles triangle here. Okay, with 90 degrees here and 45 degrees in the corners. And when you open it up, you get the square, and you just make another fold here so you can actually see the square, right? So you fold back this piece of paper. And that's what most people will do, right? So it's not very interesting. You get this square. I'm sure most of you did that. There's one annoying thing about this square. And that is that it is creased. So this is what we were doing before, right? We were just folding the top edge until it aligns with the right edge and cutting it, and we get this creased piece of paper. And now the next challenge is can you make the rectangle to the square with no creasing? How do you do that without creasing it? Now that's a bit more difficult. So here's a nice innovative way to do it. I didn't say how many pieces of paper you're allowed to use. So you could use 2 sheets of paper, right? And then you have one along its this way horizontally and one vertically. And then that's very easy to just fold over the pieces of paper at the top and at the side. And now you have a square without creases, which is nice, But then now the question is, can you do the same thing, but with one piece? So here we did it with two pieces. Can anybody think of how to do it just with one piece of paper? And I'll give you a second to think about it. So now I only have one sheet here. No cheating now. And if anybody can think of it, you can write it in the chat. So you can cheat again, right? Because as I said before, it retains the A4 pieces of paper. Actually, doesn't matter in this case. But what I can do is I can fold it in half. And then I have a pair of scissors here, so I can cut the piece of paper like this. Now I have two pieces of paper, and so I can do the same as before, right? I didn't say the square had to be exactly what size the square had to be. So here again, we have an uncreased square piece of paper. Now, I still want to ask you whether, so the next question is, can you make a rectangle to a square with no creasing? And the size of the square has to be this size, right? The length of the smaller edge of the piece of paper. And surprisingly, the answer is yes, you can do it. But you need to do something that people like to do in origami, and that is to mark some of the edges without doing full folding. So what we're trying to do, you can actually see in the last picture on the presentation. Because in order to get the right side, the right size of the piece of paper, you need to get you need to actually make an angle of 22.5 degrees in the corner. 22.5 is half of a 45 degrees angle, which we know how to do. And how do we know that we need a 22.5? Well, you can see the angles over there, and you can see. I'm not sure if I can actually try. I'm going to try and spotlight. Well, you can see to make the square. This is going to be. This is one side. Oh, I'm writing, not spotlighting, but okay. This is one side, and this is the other side of the square, and this is going to be the third side, the one down here. Okay, this is going to be the third side of the square, the uncreased square. And here, we're going to need a 45-degree angle over here, which, and to mark this, we're going to need to make this line over here with a 22.5 angle. I think you can see the rest of the angles, how they work out from this triangle. So this is the way you do it. You first take the piece of paper and make a 45-degree angle, but you mark it, you don't crease it. So, okay, so I'm just making it as if it's like a cone. I'm going to try and show you close up over here.
Yep.
Okay. And then you unfold it. And then I'll take off all these lines so you can see it better. You're going to make this in half from the same corner. So you're going to now fold the, it's pretty difficult to see over here, but if I show it in the correct light. Okay, so you're going to need to take the middle of this and sort of fold that over here. This time you do fold all the way up. Okay, because where this meets is going to be the exact place of the 45-degree angle that you need. And now all you need to do is now fold it straight to the other side to get the uncreased square of the required size.
Wow.
So that's a rectangle to a square. There are many other puzzles that you can ask. Or you can ask all shapes. Of course, there's an infinite number of shapes. So and you can do pretty much a lot of them. The next one we're going to ask is, can you make an equilateral triangle. How are we going to work this out? So again, we're going to need to think a minute what the side of the equilateral triangle is going to be. And I'm assuming that most people think it's going to be this unit, right? This short side of the A4 piece of paper or letter piece of paper, whatever. A lot of people are going to make this mistake when we do this. They say, okay, we'll take this, it'll be one side, and this will be one side, and we'll just fold it along the diagonal like this. Pretty much like we did before. So this is like okay. So I'm taking the piece of paper, I'm folding it up, folding it over like this, and tucking in the excess parts, but this is not correct. Why not? Because this is not an equilateral triangle, right? This is an isosceles triangle, and that's very easy to see because when we made although sometimes people get fooled by this, they think it is, but it's not, because when we fold it like this, right, we're making a 45-degree angle over here. So it's isosceles, not equilateral. Over here we get the 90 degrees angle, right? So the actual way to do it is we're going to use the same logic. We have one unit here and one unit here, and we're going to have this as the sides. But what we need to do is bring these two sides together and take up part of the base. And the way to do this is to fold these two to the center. So I'm going to mark the center to make this easier. So I marked the center. Now I'm going to fold it in like this. I'll show you the slide showing this. Okay, and bring them so that I keep this corner in place, and the other corner I bring to the center line. So it's going to be underneath the center line. Okay.
Question about the last thing, making the square with the angles. Somebody asked whether that would work on American paper where the ratios are different.
Yeah, because
It's the angles.
Because it's based on the 45, and I think so. I have to think about that. I'll get back to you on that. Okay. But I want to show you. So we're going to bring this side to the center here, and this side to the center here. Okay, and now you have your equilateral triangle. It's right in here. Okay, this, because it's just the side. So when we brought it to the center, what we're doing is we're taking the two sides, which are apart from each other, keeping their length and bringing them so that they meet. So this automatically creates the correct length. And I think you can see it here. And now what you need to do, tuck in the excess paper to get the triangle. The question is this maximum area triangle? And the answer is no, because here you see I made one mistake before. I forgot that it doesn't matter the size of the paper, and I wasn't using the right paper, because you could have noticed that it's still not an equilateral triangle, because this is longer than this. This should have been done with a square to, as it says, square to equilateral triangle. I'm going to quickly make this into a square, and now, okay, this is equal to this is equal to this. So all we need to do really is to bring this to the center, and now it's going to be so here the shape of this. So it does actually this it doesn't matter which paper you use as to the puzzle, but you can ask the puzzles for all papers, and you can usually always find an answer. So here now they're both folded. This is the same size as this, is the same size as this, and we have our equilateral triangle here. And I'll even do the next step, which is just to tuck in all the excess pieces of paper. Doing this down here just because it's very difficult to do this on the thing, but you do get your equilateral and uncreased. Even you don't need to crease the center, you can just mark it, so you can even get an uncreased equilateral triangles. So there, now you don't have to believe me, you can see that from a square you do get an equilateral triangle. And the question is whether this is a maximum area triangle, and the answer is, surprisingly, no. And here's a proof why not, because the first solution can be actually, it can be rotated, and you see there's excess, there's a slight discrepancy between the vertices of the triangle over here and the edge. And so you can actually sort of zoom it if you have an apple, so you can sort of, or like on your iPhone, you can sort of picture enlarging the area of this and making it maximum area. And this can also be done by trigonometry, but I haven't got time to show you because we're really it's going very quick, the time. The next question is a strip. I like strips of paper because you can do all kinds of nice things with them. You can make them into Mobius strips. How can you take a strip of paper and make it into a cube? The idea is to make a cube. Usually we use nets, and the net that most people are familiar with is, it looks like a cross, right? It has a 1 square at the top and then 3 and then another 2 below it. And there are other configurations of nets that you can make into a cube, but all of them have sort of, they look like a tree, right? They have one main body and then 2 branches sticking out, 1 on each side. So we're going to need to use the strip of paper to make this. And in fact, you can make it with just 7 squares instead of 6. Okay. And the way to do it is as follows. So you take the strip of paper, you fold it into half, you fold it into half again, and you fold it a third time into a half. And so if you want a cubic, square with each cube, you take the right size of paper, which I have done. And because now these are all squares, and here we actually have 8 squares. I'm going to cut one off. So we have 7 squares. And the way to make this now into a cube, which seems impossible, is to make these 2 branches, right? So how do you make the 2 branches? You fold the second square along the diagonal, and you fold the square before last along the diagonal, the opposite direction. And since you're using 7 squares, this means for a 6-faced cube, this means that one of the squares is you don't need, right? So you're covering it up with each time, you're covering up half a square here and half a square here at the bottom, and then this can just be folded very beautifully into a square. And you'll notice that the 2 diagonals come into a cube, and that the 2 diagonals come together really nicely over here. And you can fold the lid on this way, and you can fold the other lid, and you can tape it if you like. And you get, I don't know if you can see, it's not holding too well together, but yeah, you can see all the sides of the cube. So that's a nice way of folding a strip into a cube. Strips can be folded into other shapes. The nicest shape that I know is how to fold a strip into a pentagon. Does anyone have an idea? Just tie a knot in it. You tie a knot in the strip and flatten it down.
Simon Allen said, tie a knot.
Yeah, very good. Yeah. So this is a tribute to Martin Gardner, and a lot of the stuff that I've been showing, I should say, is attributed
to do it with chopstick paper. So this was in Martin Gardner's?
Yeah, to do in a lot of the stuff is Martin's written in Martin's books, and so
cool.
Finally, so you asked me to do some magic. So this is not quite magic, and I know you've done fold and cut, but I want to do a fold and cut because maybe there are kids watching, or adulty kids like me, or whatever. And so I want to show you something that a lot of people know, but I don't think they know it. They know all the versions of this. So the first version is how to cut a Star of David. And you do like this. You take a piece of paper and you fold it in half, okay? and then you open it up, and you can all do this with me if you have a piece of paper. And fold again in half the other half, so you're really folding it in quarters. Okay, and then what you do is you fold it in half from left to right. Okay, so we're going this way, like this. And now you bring this corner down to the quarter line, and you make sure it starts here from the half line, so it goes down over here. Something like this. Okay, and the next step is to fold it in half with the bottom. You have to fold the bottom over, okay, to make this kind of shape. So you're folding along this line over here. And now you fold it in half, right along the half line. And you can see it in the picture as well. So right along this line over here. And now you nip off the corner. Trying not to do what I did before with your finger, and you get a Star of David, and you can see it very nicely here in the cutout. And you can see it over here in this piece of paper. So quite a lot of people know this. Actually, the most well-known version is the 5-pointed star, not the 6-pointed star, the Star of David. But since I'm in Israel and this is on our flag, so I like this. I like this version.
Me too.
But a lot of people don't know that with just one more move, you can make a holy Star of David. And I'm going to show you how to do that. So let's do this again. So everyone can do this with me very quickly. Fold it in half along the, from top to bottom, along the long side. And again in half, so we're getting the quarter lines when we're looking at, okay, something like this. And then fold it from right to left, so it looks like, so it's like a booklet, right? It looks like a bit like a book. So it's the same. We're doing exactly the same thing as before. We're just going to make one more extra move at the end, okay? And now we're going to fold it over till the third line, like this. And now we're going to fold the bottom to the top corner. So we're going to fold this bit over here along this line. Okay, we get this shape. Yeah. And we fold this in half. So I'm going to do that again along the half line to get this, what looks like maybe a paper plate. Okay, so we did this. Now the next part would be to snip off, right? We finished. But I'm going to do just one more thing. And that is, when we get this, to fold this over, to fold this down, okay? I'm going to fold this down like this, just as it's shown in the picture. Okay, so all I've done is one more move. Just take this over here, fold it down. It's about a 60-degree angle. And now I'm going to cut along the line that's shown in the picture, which is this line over here, roughly. Okay, so I'm not sure. Hopefully this is going to work. And when I did this practicing, I also nipped my fingers, so you should be a bit more careful. So let's hope it worked. So you get all kinds of pieces of paper flying out as well from this. So don't worry about that. Let's see what we got here. Did this work, please? Please, please, please. Yeah, okay, a holy Star of David.
Looks great. I love it.
Okay, and finally, something that I found out yesterday when I was playing with this. Can you make a twice holy Star of David? Well, or 3 times holy, or whatever. Well, let's see. So what we're going to do is, for the last time, we're going to do the same moves again. Okay. So I'll get back for those of you who are doing this along with me. Make the fold like this. You make the folds like this. Okay, like the book. You now bring it down to the third line, like this. You fold the bottom up, like this. You fold it in half along this line over here. Now you don't snip. Now we're doing the next part. We're folding it down, okay, with about a 60-degree angle. And now what I'm going to do, okay, so I'm doing this. Now I'm going to fold it back up. Okay, so I folded it down as if I was going to do a holy, and to fold it back up to see if we can make a 2 or 3 holy. And I'm going to do exactly the same, cut across the line over here. And let's see if this works. So I have the pieces of paper left in my hand, and it doesn't look as though I get, wow. Okay, what's this? 1, 2, 3, 4, 5, 6, just 6 pieces of paper. So it doesn't seem that this worked, right? Unless you open it up and you actually get, it doesn't break. And if it does, I have one that I pre-made. It worked. It's a 6 times holy Star of David.
Wow. Wow.
Thank you very much.
Thank you.
Okay, there are 6 holes here, and this is a proper Star of David in the center.
That's great.
Okay, so I have an answer for the question before. Yes, it is specific. The rectangle to the square with no creasing is specific to A4 pieces, the pieces of paper. The way I did it, the angles will become different because it depends on the square root of 2. I can actually show that in the presentation one more time. Actually, I'll go back to this. You see, it's based on the 22.5. You need a square root of 2 over here, and the 22.5 over here comes from the fact that this is square root of 2. So we have an isosceles triangle over here. So when this is not the square, the ratio of 1 to the square root of 2, that's going to change. Okay, so it won't reach the end over here. So that's the answer to that.
Somebody asked whether you have instructions for the last thing that you did, that fabulous triple.
No, I didn't even have time to make a slide of it. I just was experimenting and found it.
Not published anywhere.
The only thing is, it's the same. It's the same as the
Previous.
The same as the holy Star of David, with one more move where you just, instead of when you have the again, I'll show you this on the.
He also asked what angle you use for the last fold. It was
about 60 degrees.
About 60, yeah.
And for the last one, maybe I'll keep my slide up in case people have other questions. So if you can see this over here, this this angle over here, can you see my spotlight?
Yes, yes, we can see what you're pointing to.
Okay, so with the Star of David 2, which is the Holy Star of David, you have this part over here, and all I did was over here. Sorry, instead of snipping it over here, I folded folding it back, straight back, okay? So straight back over here. That's the only change I did. I still need to make a diagram of it. And then cut at the same angle, basically.
Is that in this book, Yossi?
Most of the stuff here is in the book. The last one isn't, because that's because
it's new. We got to see it. Great.
Wow, there's a lot of questions, and trisecting, and that's in the book. Trisecting an angle with paper folding, which is really neat to do, and there are a lot of people. Yeah, there are a lot of people who've got some great great ideas, and there's some lovely books out as well.
And people want to know about your next book, Yossi.
My next book is it's something totally different. It's a bit like the stuff that Skona that we do in our math circles, which I think you've seen. You said we start with a magic trick, and that's basically what I do in the book, though. But it's not magic trick; it's with a puzzle. You see, the book's called Lewis Carroll's Cats and Rats and Other Puzzles with Long Tails. And the idea is behind the puzzle, behind each puzzle, you can start with one puzzle. In this case, in one of the chapters, I started with Lewis Carroll's a famous puzzle of Lewis Carroll, and you can really dig deep to sort of it's a kind of method that we use for teaching kids and adults as well, and where it's very associative. So if you take the puzzle, if you take, for instance, the cats and rats puzzles, it's just sort of a trigger to delve into a lot of stuff, to delve into Lewis Carroll, history, biography, connection to other puzzles, but also the focus is on the puzzle, not on the person. So it's also what's special about that puzzle, in what other areas of math is it connected to. So there's a lot of so we take a few puzzles and sort of dig deep and journey through quite a few areas of math, and but there are also a lot of new puzzles and solutions there.
Well, I'm looking forward to that book. When does it come out?
It's supposed to be coming out in April, I think, something like that.
Okay. And we have a new question from Glatherines. Was
One Piece was first made. Was it intuitive or reverse engineered and then worked out, or why it worked? I'm not sure. I wouldn't know. I can say about the last cut, the petaled Star of David. This thing, it was a bit of both, because once you see the pattern, the way the Star of David, or the original one and the Holy One, is made, then you know where to. It wasn't just experimenting. You know, with fold and cut magic, Eric Demain has written a lot about this. Eric and Martin Demain, they have this great paper on it. But what you're always trying to do is align things along one line. So it's pretty obvious where to snip it and where to refold it to get things aligned. So I think it's a bit of both. So you get your intuition in there, and you think, and there's a theory behind. But sometimes they would just work together and come together.
Nancy Blockman sent me a book by Gerald Lowe, a pamphlet. It's really old. It's like as old as I am. And it has some things like that, but they're all 5-pointed stars.
Yeah, a lot of stars. It's a great opportunity to say thank you. Skona and CoM, who's here very quiet, but he's doing such a lot for the community of Gathering for Gardner and the organization, and Diego Hirth, who was in doing Celebration of Mind. And for those of you who are not familiar and want to know more, there's a lot on the Gatherings website and the Celebration of Minds website. And there's a lot of great people out there doing lots of Nancy Blanchman and the Julia Robinson Festival, and many more initiatives to recreational math. So if you're interested and you're not part of the community, then there's a wealth of things, and just I'd like to encourage you to do that. And there's a lot of info on Martin Gardner, who really has been an inspiration for all of us. And so I'd like to thank you. And you're welcome also for those who want to start even to join my free online courses on FutureLearn on recreational math, which give quite a broad overview. And thank you, and thanks for the gathering, for the opportunity.
Yeah, thanks again, Yossi, and everyone who organized. Okay.
Thank you. Bye-bye.
Bye, everybody.